Section 1.7 is titled Solving Inequalities in One Variable. There are two objectives to Section 1.7. The first is to solve inequalities in one variable, and the second is to graph the solution set of an inequality on the number line. The solution set of an inequality is the set of numbers that, when substituted for the variable, results in a true statement. There are two properties used to solve inequalities: the addition property of inequalities and the multiplication property of inequalities. The addition property of inequalities says mathematically, if A is less than B, then A plus C is less than B plus C. Or if A is greater than B, then A plus C is greater than B plus C. In simple English, it means that the same number or variable term can be added to each side of the inequality without changing the original solution set to the inequality. This property works much like the addition property of equations, which said that we could add or subtract any number or variable term on both sides of the equation without changing the solution. The biggest difference is we're no longer talking about equations which contain equals and normally have a solution. Now we're talking about inequalities, which have our inequality symbols less than, greater than, less than or equal to, or greater than or equal to in them. And we now have solution sets rather than solutions. But the addition property works very much the same way it did with equations. The addition property of inequalities is used to remove a term from one side of the inequality by adding the opposite of that term to both sides. Since subtraction is defined in terms of addition, the same is true with subtraction. We can add or subtract any number or variable term on both sides of the inequality without changing the original solution set. The same is not true when it comes to multiplication. We have to be careful when multiplying or dividing both sides of the inequality by a number. The rule for multiplying and dividing by a positive number is very different than the rule for multiplying or dividing each side by a negative number. The multiplication property of inequalities has two cases or two rules. Rule 1 says that we can multiply or divide both sides of the inequality by a positive number and not change the original solution set. The second rule says we can multiply or divide both sides of an inequality by a negative number, but if we do, the inequality symbol must be reversed in order to maintain the original solution set. Now, the multiplication property of inequalities works very much like the multiplication property of equations. We use this to remove the coefficient from in front of the variable. Now, this slide is not in your PowerPoint. I added a blank slide because I want to talk about the addition subtraction properties of inequalities and the multiplication and division properties of inequalities. So let's start with a true inequality, something like 6 is greater than 4. If I add any number to both sides, and I'm randomly going to pick a 5, if I add 5 to both sides, I end up with 11 is greater than 9, which is still a true statement. This supports the fact that we can add or subtract any number on both sides of an inequality, and it won't change the truth of the inequality. Now, if I was once again to start with 6 is greater than 4 and subtract some number from both sides, and we'll use 3. If I were to subtract 3 from both sides, my new inequality is 3 is greater than 1, which is also still a true statement. Using the same inequality 6 is greater than 4, let's multiply both sides by some positive number. I'll use positive 2. Multiplying both sides by positive 2 yields 12 is greater than 8, which is still a true statement. But if we take that same inequality and we multiply both sides by a negative number, and I'll use negative 1, we end up with a negative 6 on the left and a negative 4 on the right, and we know that negative 6 is actually less than negative 4. This supports what the previous slide suggested, and that is, if in the process of solving an inequality we have to multiply or divide both sides by a negative number, the inequality symbol is reversed. That way we maintain the truth of the statement and the original solution set. Alright, let's solve the following inequalities. In example A, we have negative 7x is greater than negative 14. To remove this coefficient, we're going to divide both sides by negative 7. Since we are dividing both sides of the inequality by a negative number, the inequality symbol must be reversed. So let's go ahead and divide both sides by negative 7. On the left-hand side, we get our x. Because we divided by a negative, the inequality symbol is reversed or flipped. And on the right-hand side, we get positive 2. So we have x is less than positive 2. Moving to example B, we have negative 3/8 x is less than or equal to 6. I'm going to choose first to get rid of the fraction by multiplying both terms by the least common multiple of the denominators, which is 8. So I'll have 8 times negative 3/8 x and 8 times 6. Since at this point I'm multiplying both sides by a positive number, I don't have to worry about reversing the inequality. Cross-canceling, 8 goes into itself one time, and 1 times negative 3 is negative 3, so we get negative 3x is less than or equal to positive 48. Having removed the fractions, I now need to remove the coefficient negative 3. To do so, we're going to divide both sides of the inequality by negative 3. And because I am dividing both sides by a negative number, I have to reverse the inequality. On the left-hand side, we get an x. The inequality symbol, which was a less than or equal to, is reversed and is now a greater than or equal to, and we have negative 16. In example C, we have 6x is less than negative 18. To solve this inequality, we must divide both sides by positive 6. And since we're dividing both sides by positive 6, the inequality symbol remains the way it is. On the left, 6x divided by 6 is 1x or x. We recopy our less than, and negative 18 divided by 6 is negative 3. Alright, let's solve this inequality, and then we'll write our solution set in set builder notation. Now, right off the bat, I notice that the inequality contains lots of fractions, and the first thing I want to do is eliminate those fractions. I see denominators of 6, 4, and 12, and the least common multiple of 6, 4, and 12 is 12. So I'm going to multiply each term of the inequality by 12. This inequality contains 3 terms. So we'll have 12 times 1/6, 12 times 3/4 x, and then 12 times 11/12. Alright, let's come back now, cross-cancel, and eliminate the fractions. In the first multiplication, I can cross-cancel by 6. 6 goes into 6 one time, into 12 two times, and 2 times 1 is 2. In the next, 4 goes into 4 one time, into 12 three times, and negative 3 times 3x is negative 9x. In the last, 12 goes into itself one time, and again into itself one time, leaving 1 times 11, or 11. Having removed the fractions, next we would check for grouping symbols, which there are none, and like terms, which there are none. So let's move on to steps 2 and 3, as we can use the same 4-step process to solve inequalities that we used to solve equations. I need to get the variable term on one side and the number on the other. Since my only variable term is a negative 9x, we'll leave it there, and we'll move the numbers to the right-hand side. To accomplish that, we need to get rid of that positive 2 on the left, and to do so, we'll put a negative 2 on both sides. The 2's cancel, leaving negative 9x is greater than, on the right-hand side, positive 11 and negative 2 is positive 9. With the variable term on one side and the number on the other, it's time to remove the coefficient. To accomplish that here, we have to divide both sides by negative 9. And since we're dividing both sides by a negative number, the inequality symbol is reversed. That gives us x is less than negative 1. Now, in set builder notation, that would be the set of all real numbers such that those numbers are less than negative 1. People often look at inequalities and try to determine far too early in the process of solving that inequality if the inequality symbol will ultimately be reversed. You need not worry about reversing the inequality symbol until you get to the fourth step in our inequality and equation solving process, and that's the step where you're trying to remove the coefficient. If the coefficient of the variable term is negative, in that fourth step you will divide both sides by a negative and the inequality symbol will be reversed. If, though, in that fourth step the coefficient of the variable term is positive, then you're going to divide both sides by a positive and the inequality symbol will remain the way it was. Alright, let's graph the following inequalities on the number line. The first is the set of numbers greater than negative 2. So very quickly I'm going to put some of those numbers on this number line. Alright, we're looking for numbers greater than negative 2. That means negative 2 is not a part of the set, and we can indicate that by putting a parenthesis at negative 2. Since we're looking for numbers larger than negative 2, we're going to shade to the right, and we'll shade in an arrow to indicate that those numbers go on forever and ever. Alright, let's move to B. X or numbers greater than or equal to negative 4. Now, since we're looking for numbers greater than or equal to negative 4, recall we're going to put a bracket at negative 4. The bracket indicates that the number itself is a part of the solution set. So I have a bracket at negative 4, and we're looking for numbers greater than that, so we'll shade to the right again, and again we'll shade in our arrow. C. X is less than 0. Alright, so we're looking for numbers less than 0. The numbers less than 0 are to the left of 0. Because 0 itself is not less than 0, we're going to use a parenthesis at 0, and again the parenthesis indicates that 0 is not part of the solution set. Numbers less than 0 will be to the left of 0, so we'll shade to the left, and again we'll shade in an arrow to indicate that the shading continues forever in the negative direction. X is less than or equal to 3. Alright, so we're looking for numbers less than or equal to 3. Since 3 itself is included in the set, 3 is less than or equal to itself, we're going to use a bracket at 3. Since we're looking for numbers less than 3, we're going to shade to the left of 3. And again, we'll use an arrow to indicate that that shading continues forever. And finally, x is greater than or equal to negative 1. So we're looking for numbers greater than or equal to negative 1. Because of the equals to, we know that negative 1 is a part of the set, and we indicate that by using a bracket. And since we're looking for numbers greater than negative 1, we're going to shade to the right of negative 1, and we'll shade our arrow in again to indicate that the shading continues forever. Alright, let's solve these two inequalities, and the directions ask us to write the answer in set builder notation and in interval notation. Looking at example A, I can see that there is no need for step 1. No fractions, no grouping symbols, no like terms. Let's move to steps 2 and 3. Let's get the variable term on one side, the number on the other. To accomplish that, we're going to leave the only variable x on the left and move all the numbers to the right. And so to get rid of that negative 5, we'll put a positive 5 on both sides. On the left, the 5's cancel. We get x is greater than positive 7. Now, in set builder notation, this would be the set of all real numbers such that those numbers are greater than 7. In interval notation, our solution set starts at 7. 7 itself is not a part of the set, so we'll use a parentheses at 7. Since we're looking for numbers greater than 7, those would be to the right of 7 and would extend on forever, and so we'll use the positive infinity symbol. Moving to B, there is no need for step 1. Moving forward to steps 2 and 3, we need to get the variable on one side, number on the other. Since the only variable y is on the left, we'll leave it there and move all the numbers to the right. To accomplish that, we need to get rid of the negative 8, and so we'll add a positive 8 to both sides. The 8's cancel, leaving y is less than or equal to negative 3. In set builder notation, that would be the set of all real numbers such that those numbers are less than or equal to negative 3. In interval notation, our solution set starts at negative 3, and because of the equals to, we know negative 3 is a part of the set. To indicate that, we'll use a bracket at negative 3. Since we're looking for numbers less than negative 3, that would be to the left of negative 3 and would extend to negative infinity. Problem C. Very quickly I can see that we already have the variable on one side and the number on the other. So the only step that's required is the fourth step, and that's to remove the coefficient. To accomplish that here, we're going to go ahead and divide both sides by 3, giving us x is less than 4. In set builder notation, that would be the set of all real numbers such that those numbers are less than 4. In interval notation, our solution set starts at positive 4. 4 itself is not a part of the set because 4 is not less than 4, so we'll use a parentheses at 4, which indicates that 4 is not part of the solution set. Since we're looking for numbers less than 4, that would extend to the left all the way into negative infinity, and so negative infinity would be our other boundary. Looking at D, I can see once again that the variable is on one side, the number is on the other, so the only step required is the fourth and final step of removing the coefficient. In this case, to remove the coefficient, we must divide both sides by a negative number, specifically negative 6. Recall, anytime we multiply or divide both sides of an inequality by a negative number, the inequality reverses. So this will give us b is less than negative 4. In set builder notation, this would be the set of all real numbers such that those numbers are less than negative 4. In interval notation, our solution set starts at negative 4. Since negative 4 is not a part of the solution set, we'll use a parentheses. Since we're looking for numbers less than negative 4, those would extend to negative infinity. And then there's our parentheses. All right, the next two examples ask us to solve the inequality and then simply write our answer in interval notation. Looking at example E, I see there's no need for step 1. There are no grouping symbols, no fractions, and no like terms to combine. Moving to steps 2 and 3, we need to get the variable term on one side and the number on the other. Recall, I prefer my variables on the left-hand side, so I'm going to choose to get rid of the variable term 4x on the right-hand side. And to get rid of a positive 4x, we're going to put a negative 4x on both sides. Combining the x's, positive 5 and negative 4 is positive 1, so we get 1x or x plus 4 is less than negative 10. With the variable term on the left-hand side, let's move all the numbers to the right-hand side. To accomplish that, we need to get rid of the positive 4, so we'll put a negative 4 on both sides. The 4's cancel, giving us x is less than negative 14. Now, in interval notation, our solution set starts at negative 14. Because negative 14 is not less than itself, we would use a parentheses at negative 14. Since we're looking for numbers less than negative 14, that would extend to the left of negative 14 to negative infinity. Moving to F, I can see there's no need for step 1. We have no fractions, no grouping symbols, no like terms. Moving to steps 2 and 3, we need to get the variable term on one side and the number on the other. Since our only number is positive 10, let's leave it there, and let's move the negative 3x to the opposite side. To do so, we'll add a positive 3x to both sides. On the left-hand side, the x's cancel, giving me 10 is less than or equal to 10x. With the variable term on one side and the number on the other, the fourth and final step is to remove the coefficient. So we'll divide both sides by 10, and that gives us 1 is less than or equal to x. Now, this is the first example where the variable term appeared on the right-hand side of the inequality. Anytime we're asked to read inequalities, put them in interval notation, or graph them, it is always best to start the inequality or start reading the inequality from the variable towards the number. Read that way, this is x is greater than or equal to 1. Since we're looking for numbers 1 or larger, and 1 is a part of the solution set, we're going to use a bracket at 1. And since we're looking for numbers larger than 1, we would shade to the right, which would take us to positive infinity. Alright, let's tackle G. Right off the bat, I see I have a grouping symbol, so there is the need for us to use step 1. To eliminate that grouping symbol, we'll distribute positive 5 into the parentheses. Positive 5 times 2x is positive 10x. Positive 5 times positive 7 is positive 35. And let's recopy the right-hand side of the inequality. Our grouping symbols have been eliminated, but we have no like terms to combine. So let's move to steps 2 and 3. Let's get the variable term on one side and the number on the other. To move all the variables to the left-hand side, we need to get rid of that negative 4x on the right-hand side. And to do so, we're going to put a positive 4x on both sides. Combining the x's, positive 10 and positive 4 is positive 14. So we get 14x plus 35 is greater than, on the right-hand side the 4x's cancel, and we're left with a negative 7. Since we move variables to the left, we have to move numbers to the right. To accomplish that, we need to get rid of the positive 35, and so we'll put a negative 35 on both sides. The 35's cancel, leaving 14x is greater than negative 42. Steps 2 and 3 are complete. We have a variable term on one side and a number on the other. The fourth and final step is to divide. Since we're dividing both sides by a positive number, specifically positive 14, the inequality remains the way it is, and we get x is greater than negative 3. In interval notation, we're looking for numbers larger than negative 3. Negative 3 itself is not a part of the set, so we'll use a parentheses, at negative 3. Since we're looking for numbers larger than negative 3, that would extend to the right on the number line to positive infinity. Looking at example H, I can see the need for step 1 once again because we have grouping symbols on both sides. So let's distribute. A positive 2 on the left-hand side of the inequality, a positive 7 on the right-hand side of the inequality. Positive 2 times 5x is positive 10x. Positive 2 times negative 8 is negative 16. On the opposite side of the inequality, positive 7 times x is positive 7x, and positive 7 times negative 3 is negative 21. Grouping symbols are gone. There are no like terms to combine. Step 1 at this point is complete. Moving to steps 2 and 3, we need to get the variable term on one side, the number on the other. To move all the variables to the left, we need to get rid of that positive 7x on the right, and so we'll put a negative 7x on both sides. Combining the x's, positive 10 and negative 7 is positive 3. So we have 3x minus 16 is less than or equal to. Those 7x's cancel, and we get a negative 21. Since we move variables left, we have to move numbers to the right. Let's get rid of the negative 16 by putting a positive 16 on both sides. The 16's cancel, leaving 3x is less than or equal to negative 5. With the variable term on one side and the number on the other, steps 2 and 3 are complete. Our fourth and final step is to remove the coefficient. We'll divide both sides by 3, giving us x is less than or equal to negative 5/3. Since our solution set is all numbers less than or equal to negative 5/3, negative 5/3 is a part of the solution set, and we'll indicate that by putting a bracket on negative 5/3. Since we're looking for numbers less than it, they would extend to the left all the way to negative infinity. Alright, example I. Once again, I can see grouping symbols, so we have the need to use the first step. Let's distribute to eliminate those grouping symbols. On the left-hand side, we'll distribute a negative 3. Negative 3 times x is negative 3x. Negative 3 times negative 4 is positive 12. On the right-hand side, we must distribute negative 2. Negative 2 times x is negative 2x, and negative 2 times negative 7 is positive 14. With the grouping symbols eliminated, both sides of the inequality contain like terms, so let's combine those. On the left-hand side, those like terms are variable terms. A positive 2x and a negative 3x is a negative 1x. On the right-hand side, the like terms are constant terms or numbers. A positive 4 and a positive 14 is a positive 18. At this point, step 1 is complete. Grouping symbols have been eliminated and like terms have been combined. Moving to steps 2 and 3, we need to get the variable term on one side and the number on the other. To move the variables to the left, we need to get rid of the negative 2x on the right, and to do so, we'll put a positive 2x on both sides. Combining the x's, negative 1 and positive 2 is positive 1x, or just x, so we have x plus 12 is greater than or equal to 18 as the 2x's cancel. With the variables moved to the left, all the numbers have to be moved to the right, and so to get rid of that positive 12, we'll put a negative 12 on both sides. That cancels the 12's and gives us x is greater than or equal to positive 6. So our solution set is all numbers greater than or equal to positive 6. Since 6 is itself a part of the set, we'll use a bracket at 6. Since we're looking for numbers larger than that, it would extend to the right of 6 to positive infinity. Our next two examples contain fractions, which shows us that we have to use the first step to eliminate those fractions. In example J, I see denominators of 8 and 6, and the least common multiple of 8 and 6 is 24, so we're going to use 24 to eliminate those fractions. J has 3 terms in the inequality, and all 3 terms must be multiplied by 24. Simplifying, 24 times x is 24x. cross-canceling in the first multiplication. 8 goes into 8 one time, into 24 3 times. Negative 3 times 3 is negative 9. 6 goes into 6 one time, into 24 4 times. 4 times 5 is 20. Okay, we've eliminated the fractions. There are no grouping symbols, nor are there any like terms on the same side of the inequality. So step 1's done. Let's move to steps 2 and 3. Let's get the variable term on one side and the number on the other. Since my only variable term is a positive 24x, I want to leave it on the left and move all the numbers to the right. To accomplish that, we need to get rid of the negative 9. So we'll put a positive 9 on both sides. The 9's cancel, leaving 24x is less than 29. With the variable term on one side and the number on the other, our fourth and final step is to remove the coefficient, so we'll divide both sides by 24, giving us x is less than 29/24. Our solution set then is all numbers less than 29/24. Since 29/24 is not less than itself, it is not part of the solution set, and so we'll use a parentheses at 29/24. Since we're looking for numbers less than it, that would extend to the left in the direction of negative infinity. Moving on to k, once again I see we have fractions. Denominators of 2 and 4 share a least common multiple of 4, and so we must multiply each term in this inequality by 4, and there are 4 terms. Beginning to simplify, positive 4 times 2x is positive 8x. Next we'll cross cancel. 2 goes into 2 one time, into 4 two times. Negative 2 times 1 is negative 2. On the right hand side, positive 4 times x is positive 4x. And cross canceling 4 into itself one time, and again 4 into 4 one time, and 1 times 3 is 3. With the fractions eliminated, we can see that there are no grouping symbols, nor are there any like terms to combine. Moving to steps 2 and 3, we need to get the variable term on one side and the number on the other. To eliminate the positive 4x on the right and move all the variables to the left, we would put a negative 4x on both sides. Combining the x's, we get 4x minus 2 is less than positive 3. With our variables moved to the left, we need to get all the numbers to the right. To accomplish that, we need to get rid of the negative 2, and so we'll put a positive 2 on both sides. The 2's cancel, giving us 4x is less than positive 5. With the variable term on one side and the number on the other, the fourth and final step is to remove the coefficient, and to do so we must divide both sides by 4. That gives us x is less than 5/4. Now, in interval notation, we're looking for numbers less than 5/4. Since 5/4 is not a part of the set, we'll put a parentheses at 5/4. Since we're looking for numbers less than it, that would extend to the left to negative infinity. Okay, here we go. Problem L, another one with fractions. Okay, so let's begin in step 1. Let's eliminate those fractions. I see denominators of 8 and 6, the least common multiple of which is 24. There are 4 terms, so let's go ahead and multiply all 4 terms by 24. And let's begin simplifying. 24 times 3x is 72x. Cross-canceling, 8 goes into 8 one time, into 24 three times, and 3 times 5 is 15. 24 times 2x is 48x. Cross-canceling, 6 goes into 6 one time, into 24 four times, 4 times 5 is 20. Okay, so we've eliminated the fractions. There are no grouping symbols, nor are there any like terms. So let's move to steps 2 and 3 and get the variable term on one side, the number on the other. To move the variables to the left, we need to get rid of the positive 48x on the right, and to do so, we'll put a negative 48x on both sides. Combining the x's, positive 72 and negative 48 is positive 24, so we get 24x plus 15 is greater than, those x's cancel, and we're left with 20. Since we move variables to the left, we have to move numbers to the right. To accomplish that, we'll get rid of that positive 15 by putting a negative 15 on both sides. The 15's cancel, leaving 24x is greater than 5. With the variable term on one side, the number on the other, the final step is to divide to remove the coefficient. We'll divide both sides by 24. X is greater than 5/24. Now our solution set is all numbers greater than 5/24. 5/24 itself is not a part of the set, so we're going to use a parentheses at 5/24. Since we're looking for numbers greater than that, they would be to the right of positive 5/24 and would extend forever in that direction to positive infinity. Okay, the remaining examples on this PowerPoint are the U-tries. You can, as in the past, do those yourself and then use the document found in Canvas under Modules in Unit 1 to check your answers. Or you can simply begin the homework.